Hi there, folks. This is the Unit 5 review, and I am the amazing Mr. Jansen, so away we go. If we take a look at this first one, it asks us to write this thing in standard form. Remember, standard form is the one where x and y are on the same side. It's ax plus by equals c. And so we got to get x and y on the same side. Then we got to make sure there's no fractions and we don't start with a negative. Okay. So to move the x, anytime we want to move something, we use addition or subtraction to move it to the other side. Since this is a negative, I'm going to add that 2/3 x over. And it gives me this. And now the other stipulations with standard form is I can't have any fractions and I can't start with a negative. Well, this one doesn't start with a negative, but I do have a fraction. To eliminate fractions from any equation ever, I multiply through by the common denominator. Okay, and this is my distributive property here. So that gives me a 2x plus 3y equals 12. Now that's it. That's standard form. Ax plus by equals c. The next one asks me to write this one in slope-intercept form. Slope-intercept form, anytime, no matter what format it's already in, to put it in slope-intercept form, I have to solve for y. So here I got to move the x over to the other side. Since it's a negative 2x, I'm going to add 2x to each side. That leaves me the 3y equals 2x plus 10. And now I have to divide each side by the 3. Again, I'm just solving for y. And again, this is my distributive property. Even though it's division, I have to do the 2 divided by 3, which is 2/3. I just leave it as a fraction. Then I have to do the 10 divided by 3, which also doesn't divide very nicely, so I'll just leave it as 10/3. Okay. So again, standard form, everything on the same x and y on the same side, no fractions, can't start with a negative. And then slope-intercept form, solve for y. Okay. This one asked me to write the equation in slope-intercept form. It gives me the slope here, and really, I always kind of want to start with point slope form as kind of my go-to. So this one, the slope is right here, negative 4/3, and then it goes through this point. So I do y minus the y value, so that gives me y plus 3 equals negative 4/3, that's the slope, times x minus the x value, which is a minus 3. And now I solve for y, because that's how I write things in slope-intercept form. So it's a little bit of distributing, so I distribute this guy. That's a negative 4/3 x. Negative times a negative is a positive, so it's a plus, and that ends up being a 4 when I add those together. And now I finish solving for y. I subtract that 3 from each side. I get negative 4/3 x plus 1. Okay. The next one asks me to write the equation in point slope form. And really, again, that's the one I start with, so I just go right to point slope form. It's y minus the y value, so that ends up being y plus 8 equals the slope times x minus the x value, so it ends up being an x plus 2. And that's it. I don't change it from here because it asked for the equation in point slope form. Okay. A lot of times students will take these things a little bit too far. Make sure you're looking at what format it asks for. This one, it asks for slope-intercept form again. So slope-intercept form. Again, I'm going to start with point slope form, but I'm not given the slope this time. I have to find it. So to find the slope, I do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And be careful there, it's minus a negative 2. So let's see, that gives me a negative 5 over a positive 10, which is a negative 1/2. So there's my slope. Now I just put it in point slope form. And you can use either one of those points. Maybe I'll use the second one, since they're a little bit different. I'm less likely to make a mistake. So y minus the y value, that gives me a y plus 3. Here m, which is the slope, times x minus the x value. And I distribute. And the reason I'm distributing is because I want to get to slope-intercept form. I have to solve for y this time. And if I use the other ordered pair, it will give me the same answer. Let's see, that's a plus 4. And now I subtract. So I get y equals a negative 1/2 x plus 1. Okay. The next one, very similar, but asks for point slope form. I still need to find the slope, so I do my y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And let's see, that gives me a negative 10 over a negative 2, which gives me a positive 5. And now to put this in point slope form, I pick either one of the points. If I use the first point, y minus the y value equals the slope times x minus the x value, then this would be my answer. But if I use the second point, the y minus the y value is y plus 6 equals the slope times x minus the x value. This would be my answer. Okay, and either one of those would be acceptable for this particular question. Okay. The next one asked me to write it in standard form, giving the x-intercept and the y-intercept. Again, always think of these things as ordered pairs. The x-intercept is the ordered pair -4, 0. The y-intercept is the ordered pair 0, 3. Okay? And so for this one, I need to find the slope again. So I find the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that gives me a 3 over 4. And from here, normally I would go to point slope form and then rearrange it to slope intercept form and then take that to standard form. But because I'm given the y-intercept, when I'm given the y-intercept, that's the only time I should go right to slope intercept form. So I would call this thing y equals -3/4, positive 3/4. I don't know where I got that negative from. So 3/4 x and then plus 3. Y equals mx plus b. The b is the y-intercept. And now to put this thing in standard form, again, I got to get x and y on the same side, so I'm going to subtract the 3/4 x. Just moving this thing around. That gives me a -3/4 x plus y equals 3. But remember, I'm not allowed to start with a negative, and I can't have a fraction. So to get rid of the fraction, I multiply by 4. I multiply through by the common denominator. To get rid of the negative, I just make that a -4. So now I'm multiplying each side by -4. And then again, it's my distributive property here. So as I distribute that thing, negative times a negative is a positive. That gives me a 3x minus 4y equals a -12. And now this thing is in standard form. Done and done. Okay? The next one just asked me to give the equation. And that should be a hint. It might not be in one of my typical formats. So again, I still want to start off the same way. I'm going to find the slope here. So to find the slope, I do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's going to give me a 0 over a -7, which equals 0. And so if I'm talking about a slope of 0 here, slope of 0 means I have a horizontal line. Well, horizontal lines are always y equals a value. And if I look at my ordered pairs, look at the y value. It's -3 every time. The equation is y equals a -3. Okay? If I were to get a slope that's undefined, if I get a 0 in the denominator here, then that means I have a vertical line, so I would do x equals a number. So I would just look at the ordered pairs for the x value. Okay? These guys asked me to find the slope, then the slope of the parallel line, then the slope of the perpendicular line. And so the first thing I do, let's just do my slope formula here. So let's see, slope y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that gives me a 10 over 5, which is a 2. So that means the slope of my line is 2. The parallel line, remember parallel lines have the same slope, so the slope of the parallel line would also be 2. And then the perpendicular line has to be the opposite reciprocal. So if you think of this guy as 2 over 1, that's a positive 2 over 1. Opposite means change the sign. Reciprocal means flip the fraction. So opposite reciprocal means change the sign and flip the fraction. So instead of positive 2 over 1, it's negative 1 over 2. I change the sign and flip it. Okay? And that's how I deal with parallel versus perpendicular lines. This guy's same kind of thing. If I count the rise over run here, looks like I go down and over. See, it's down 1, 2, 3, 4, 5, 6, and then over 3. So the slope this time is down 6 over 3, which is a -2. So that means the slope of the parallel line would also be -2 because parallel lines have the same slope. The slope of the perpendicular line, so this is -2 over 1, would be positive 1 over 2. Okay, it's opposite reciprocal. And that's it. If I look at these guys, it says determine if the lines are parallel, perpendicular, or neither. So going back to what we just talked about, we just need to see, are the slopes the same? If so, they're parallel. Are the slopes opposite reciprocals? If so, they're perpendicular. If it doesn't meet either of those things, then they're not parallel or perpendicular. We'd say they're neither. Okay? And so the first thing I need to do is I need to make sure each of these things is in a format where I can identify slope. See, like if I look at this first equation gives me a slope. It gives me a slope of positive 2 because it's in slope-intercept form. But this second equation, it's in standard form. Standard form doesn't give me the slope, so I need to put it in something like slope-intercept form, so I'm going to solve for y. Okay? I subtract the x from each side. And now I divide by the 2. I'm solving for y so that I can see what this thing looks like in slope-intercept form, so I can see what the slope is. Again, here's my distributive property. A lot of students have trouble with this one. There's a 1 right here. Think of it as a fraction. Negative 1 over 2, just negative 1/2. Negative 1/2 s. And then negative 10 divided by 2, negative 5. Okay? And so when I look at this guy, it gave me the slope. The slope is right here. So the slope of this one is a negative 1/2. So now I ask myself, are they the same? No. Are they opposite reciprocals? If I change the sign and flip it, will they give me the same value? And the answer is yes. These are opposite reciprocals. One is positive 2 over 1. The other one's negative 1 over 2. So that means these lines are perpendicular. Okay? Well, look at the next one again. I have to look at these slopes. Well, lucky for us this time, the slopes are in these are each in slope-intercept form. The first one gives me a slope of 3 over 4. The next one gives me a slope of 4 over 3. So I ask myself, are these the same? And the answer is no. One's 3 over 4, the other's 4 over 3. Okay? Are they opposite reciprocals? And once again, the answer is no, because they're not opposite reciprocals. They're just reciprocals. They're just flipped. They're not opposite and flipped. So these are not parallel and they're not perpendicular. The answer here is neither. Okay, because remember, they have to be opposite reciprocals. Change the sign and flip it. And if I look at this last one, again, I have to make sure this is in a format where I can identify the slope. This one gives me the slope of 3 over 2. The next one is not in the right format. This thing is not in a format that gives me slope. It's in standard form, so I have to solve for y. Let's put it in slope-intercept form. So I'm going to subtract the 3x. And now I have to divide each side by this negative 2. And once again, this is my distributive property as I go through this. So it's negative 3 divided by negative 2. Negative divided by negative is a positive. 3 over 2 is 3 over 2. And then here, 6 divided by negative 2 is a negative 3. And so now when I look at the slope of this guy has a slope of 3 over 2. So I ask myself, are the slopes the same? And the answer is yes, they're the same this time, which means these are parallel lines. Okay? This one, give the slope of the line in slope-intercept form that's parallel to y equals 1/4 x plus 2 and passes through the point 4, negative 9. So once again, I'm doing the same thing that I did on the first page here, but I just identify the slope in a little bit of a different way. Here it says we want to be parallel to this guy. Well, this guy has a slope of 1/4. Parallel means my slope has to be the same, so it's also going to be 1/4. Okay? And now, just like I've done before, I always start with point slope form. Y minus the y value gives me y plus 9 equals slope times x minus the x value. And now I want it in slope-intercept form, so I have to solve for y. A little bit of my distributive property. And now I have to subtract that 9 from each side. And that's it. The next one, same kind of thing. It asked me to put this thing in slope-intercept form also. And so slope-intercept form, I want to be perpendicular to this guy this time. So perpendicular means my slope has to be the opposite reciprocal. So instead of negative 5, which is like negative 5 over 1, I'm going to do positive 1 over 5. I change the sign and flip it. And now once again, I start in point slope form. Y minus the y value equals the slope, which is 1/5, times x minus the x value. And now from here, I solve for y. I'm going to use my distributive property once again. Except this time, y minus 0 is just y, so that I'm not going to have any need to add something to the other side. And that's a 1/5 x minus 2/5 when I multiply that out. Okay? Here it says your science class is taking a field trip to an observatory. The cost of the presentation and tour is $60 for the group, plus an additional $3 per person. Write an equation that gives the total cost C as a function of the number of people P. Okay, and here's the thing: if you want to write this as y and x, that's fine. But really, we just need to determine the format. Sometimes these equations are presented to us in point-slope form, sometimes in standard form, and sometimes in slope-intercept form. Okay, standard form, one of the values. Standard form is when kind of the values are arbitrary in terms of which one is dependent and independent variables. Point slope, it'll give us one of the values kind of as an ordered pair in some way. And slope intercept is kind of when we look for, there's a rate, but then there's also a value that's kind of tacked on there for no reason. And so, not necessarily for no reason in the context, but in this one, that $60 is just kind of tacked on there all by itself, okay? And so really, this is going to be slope intercept form. $3 per person, that's the rate, and then plus the $60, okay? And then doing what the question asked me to do, instead of the y, we would say the cost equals $3 per person plus $60. And see, we're just using variables that make a little bit more sense there, all right? The next one then asked me to use this equation, says if there's 23 people in the group, what's the total cost? So now instead of 3 times per person, it's $3 still per person, but now we know it's 23 people, okay? And so for this one, now it becomes a job for our calculators, where we just do the 3 times the 23 and then add that 60 on there. And it looks like we get $129. For these guys, it asks us to just determine if this is a positive, negative, or no correlation. And so we're kind of looking for a linear pattern here. We're looking to see, can I draw a line that approximates the data, and will that line have positive or negative slope? So like this one, it looks like I could draw a line that kind of estimates the data here, and that slope is positive. So this one is positive correlation. Okay. The next one, I could try drawing some lines, and maybe I think that looks good, or maybe you think this looks good, or as we kind of start to try to draw these things, none of these look like they really match the data well. The points are kind of scattered everywhere, so we would say this one is no correlation. And then the last one here, it looks like we can draw a line that approximates the data by drawing one that kind of goes down like this. And that line has a negative slope, so we say there's a negative correlation. And again, it's not really about the fact that it's positive or negative. It's about the fact that as one is going up, the other one is going down for negative. And in the positive correlation, as one value goes up, the other value also goes up. That's why it's positive correlation. That slope is just a nice little trick for determining that. Okay? This one, it says the table shows the number of golf facilities in the United States during the period of 2001 to 2005. And so we're just going to graph this thing. And again, whenever we're dealing with time, with years like this, it's always good to rescale the graph. So I'm going to call 2001 year 1, 2002 would be year 2, 3, 4, and 5. And notice how I kind of spread that out. Yeah, I went by 0.25 on that x-axis, but that's okay. Up here, I'm going to draw that little zigzag. Remember, when you draw that little like lightning bolt, it means you're skipping some values. And so maybe I'll start here at 15 because that makes the most sense. And then I think I'll go by kind of the same scale, I think. 15.5, this would be 16, 16.5, and then 17. Okay, and that gives me a nice spread out because we want to use as much of the graph as possible because it makes it easier to kind of look at our data and identify some things. Okay, so now I'm going to plot these 115.7 right around here, 216 here, 316.2, 416.6, and 516.9 right around there. So when we look at this thing, the scatter plot is showing us that this has a positive correlation, which means I can then draw a line of best fit. And remember, when I'm drawing a line of best fit, I just want something that kind of approximates the data well. So maybe I'd take something around here and draw it kind of like this. Okay. When I look at that, that looks like a pretty good estimation. And everybody's answer is going to be a little bit different, and that's okay. our answers shouldn't be exactly the same here, but now we just have to kind of draw an estimate of this thing. When I look at this, I'm going to say y equals, I just need an approximate slope here. It looks like I go through this point right here. Let me grab a different color. Looks like I go through a nice point right there. And then as I keep going, it looks almost like it goes through this point right here pretty well as well. So it looks like I go up 1, 2, 3 blocks, which essentially is 0.75. Because remember, each block is 0.25. And then I'll go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. 10 times 0.25 is 2.5. And so just be aware of the scaling here. Even though I went up 3 and over 10, that doesn't necessarily mean that that's what's going to be. Now, with this one, because I scaled them each the same, if I do the 0.75 divided by the 2.5, it gives me 0.3. So in this one, it will happen to be the same only because the x and the y are scaled the same. All right. And then if I kind of estimate where that x-intercept, or sorry, that y-intercept is, it's somewhere between 15.25 and 15.5. So I'm just going to say like 15.3 or something like that. Okay. Again, we just want to kind of estimate that. And let me clean this guy up a little bit. Just write it as decimals. That's the most valuable way to write this when we're talking about scatter plots and best fit lines. Okay, so I'm going to use this equation. All right, your equation might be slightly different, and that's okay, which means your next answer is going to be slightly different, but they should be pretty close. So it says predict the number of golf facilities in 2014. Keep in mind, I rescaled this, so in my graph, 2014 would actually be a value of 14. So that means I'm going to plug a value of 14 into this guy. And so it's really important that you use the x value from your equation and from your graph, and not the actual year itself. So 0.3 times the 14 plus the 15.3 looks like about 19.5. And also another thing to keep in mind when you look at this, it said that that was in thousands. So that means really that the answer here is 19,500. Okay, is the best way to interpret that. So a little bit of interpretation. This one, it says to predict the year in which the number of golf facilities will reach 18,000. So again, think about it though. That means my y value would be 18 because the graph is scaled a little bit differently. So now I do 18 equals 0.3x plus 15.3. Okay, and now I'm going to solve this thing for x. See, the previous example, I plugged a value in for x. Now I'm plugging a value in for y. So it's all about the kind of the interpretation of this thing. Okay. So now I'm going to subtract that guy from each side. 18 minus the 15.3 gives me a 2.7. And I'm going to divide each side. So it looks like I get x equals 9. So about 9 golf facilities. Okay? Oh no, in about 9 years. Sorry, I almost interpreted that incorrectly. So 9 years, see, that's not my answer. I don't want to leave that as 9. I'm going to say that the answer there, and even though that was kind of right in the middle of some of my data that I had before when I think about the previous example, 9 makes sense because 2014 is going to be 19,500. So 9, I would interpret that as the year 2009. And again, that goes back to kind of the scaling of my graph. Okay. The last one here is kind of like an error analysis question. Student identified the following equation as the line of best fit for the scatter plot below. We're going to graph their equation and then say if we should change it to make it more closely represent the data. So the first thing we want to do is graph their equation. So they have a y-intercept of 10 and then a slope of 0.25, which is like 1 over 4. But look at the scaling of this thing. We're going by 5s here. So like if I go up 1 block, that's actually up 5. And then down here, it looks like I'm going by 10s. So like if I want to go by blocks of 5, up 5, which is 1 block, would actually be over 20. And so here, if I go up 5, I have to go over 20. And then if I go up 5 again, over 20, up 5, over 20. And so we got to be really aware of the scaling in the graph. And so when we look at this thing, the first thing we have to look at is the slope.
And in my opinion, the slope looks pretty good because we have basically a line that's parallel to the data. So we want to keep that slope, but maybe we want to change the y-intercept. We want to lower this line. So maybe we bring it down to something like 5 and then do the exact same slope. And it gives us something more like this. Okay? And so when you look at something more like this, that looks like a much better line of best fit. Okay? And so what we want to do in order to kind of change this thing for the better, so we want to say, hey, you know what? We're going to call this y equals, I can't get my, let me go back to this other color. So y equals, we're going to keep the same slope because that looked good, but now we're going to change the y-intercept. We're going to just change it to a 5. Okay? I hope this was helpful, and good luck on your test.